All right, guys, lesson 7, using graphs to find average rate of change. One thing I want you to jot down, rate of change is going to be the slope of these graphs. And remember, to get slope, you subtract the y-coordinates from the x-coordinates. That will be helpful for us here today. So who do you agree with? Tyler says the temperature dropped faster between 4 and 6. Looks like it dropped 8 degrees there in 2 hours. Maya says the temperature dropped faster between 6 and 10. So in 4 hours, it dropped 9 degrees. So who do you agree with? Well, the temperature dropped more over this time frame. So you could say Maya, it dropped an extra degree. Or maybe you figured out how much it dropped per hour. This one would be 4 degrees per hour. This one would be 9 divided by 4 is 2¼ degrees per hour. Then maybe you would say it was Tyler. So again, whichever one you say, defend it. Okay, explain. It does say that. Watch that on these homework problems. Why? Why did you pick the one that you did? Okay, question number 2. We are graphing temperature change again, an hour since noon. Temperature change, independent variable, that is my x value. Temperature in degrees Fahrenheit after those times is the y value, the dependent variable. So find the average rate of change between noon and 1. So hour since noon, that means this one right here is noon. And 1. So here are my points. At noon it was 18 degrees. At 1 it was 19 degrees. So that's an easy one, right? It raised 1 degree in an hour. 1 degree Fahrenheit per hour. Could use slope there where you subtract the y's, subtract the x's, and you get 1. Guessing they will not all come out that nice, but the formula will work no matter what. Now it's asking between noon and 4. So noon is still at 0:18. 4 o'clock would be 4 and 25. This one doesn't come out quite as nice, so I'll just use the formula. Subtract the y's. Remember, the order you do them in doesn't matter. You just have to be consistent. So if I do 25 minus 18, I gotta do 4 minus 0. Y is on top. Rise over run. 25 minus 18 is 7. 4 minus 0 is 4. 7 divided by 4 is 1.75 degrees per hour. Okay, noon and midnight. So noon is the same that we've had all 3 problems here. Midnight is 12 and 7. So 7 minus 18, 12 minus 0. So 7 minus 18 is negative 11, 12 minus 0. So this one's going to be negative, makes sense, the temperature went down. 11 divided by 12, I've been doing decimals, so I'll do it again. Doesn't come out perfect, but it comes out to be 0.92 degrees Fahrenheit, and that is a negative, or you could say the temperature is dropping. Maya remembered Tyler's disagreement, or do you remember that? Use average rate of change to show that, so we kind of already did that, but we could show it again. 4 and 25, 6 and 17. The other one is 6 and 17, and 10 p.m. and 8 degrees. So 17 minus 25 over 6 minus 4. So that's negative 8 divided by 2. That is 4 degree drop per hour, as we mentioned in problem 1. 8 minus 17. 10 minus 6, so negative 9 divided by 4, negative 2¼ So I would say a 4-degree drop per hour is the way I would have chosen it. The Are You Ready? What interval did temperature decrease the most rapidly? Okay, where did the temperature go down the sharpest here? Okay, you can look at the chart. Look like we had a 6-degree drop here between 5 and 6. I don't think any other one was more than a 6 degree. So I would say between 5 and 6 p.m. How about increase? Where did it increase the most? Increase by 1, no change, 5, up 1 here. So I would say a 5-degree increase is the same, or is the biggest. That was between 3 p.m. and 4 p.m. And question number 3. Estimate the average rate of change in the population of each state between 1970 and 2010. Okay, it does say estimate. We don't know these exact figures, so we're going to have to guess a little bit. All right, so the year is my X, it appears. So we're going to do California first. That's where I have my dots. 1970, the population is about 20 million. And in 2010, population about 37, 38. Again, it's an estimate. Subtract the y coordinates, 37 minus 20, 2010 minus 1970. Rise over runs, so this is going to be 17. 2010 minus 1970, that should be 40-year difference. 17 divided by 40, about 0.425. Remember, that's in millions of people per year. So almost 500,000 population growth per year. All right, let's check Texas. Same years. 1970, 10, 11, 12, we'll go 11. And in 2010, kind of looks right in the middle, we'll go 25 million people. Subtract the Y's, subtract the X's, 25 minus 11. This is still going to be 40 years, so 14 divided by 40. 0.35 million people a year. So let's answer the question. What does the rate of change mean? What does this mean? That would be population change per year. That is what the slope means in this problem. So on average, California is growing at a faster rate. Line is steeper. Which state's population grew more quickly between 1900 and 2020? Sorry, 2000, goodness. So from the beginning to the year 2000, 1 century, which one grew more? Well, they're starting at the same year. I would say it's pretty obvious that the blue one, which would be California, grew more. Okay, it has a greater slope. If it wanted numerical values, we could figure that out again. I can see that one is steeper than the other one. Okay, so just remember, rate of change is the same as slope. Good reference here again. Got a positive rate of change and a negative. Very good example on page 181 for you. I think the homework is pretty self-explanatory starting on page 182. Again, watch for the words explain. There are 7 questions for it to answer. Excuse me, the first 4 are from this unit. 5 and 6 are from this unit, just a couple lessons prior. And lesson 7 is a review from unit 3. So I think we should have no trouble. Watch for the word explain, and make sure you do so. Everything else should be just fine. So 182 to 184 due tomorrow.